So what are some of the typical challenges that you might find in a high-speed printed circuit board? Well, if you look at these little vignettes on this cross-section, you can see, looking at number one, it's very common to have excess capacitance in a through hole. And number two, you can have localized crosstalk between vias and differential traces, whether it be microstrip or strip line. And number three, you can have localized changes in conductor width. So if there's maybe a little nick in one leg of the differential pair, that's going to cause impedance discontinuities, which is going to give reflections and, of course, all kinds of havoc with eye diagrams. Number four, you can have a similar problem if a piece of solder falls on one half of a differential pair and gives you some excess capacitance. Number five, you can have reflections due to the via stub. Six, you can have non-uniform dielectric material. There's no such thing as a perfectly homogeneous dielectric system. And so this material that you use as the dielectric is going to become even more critical in the higher speeds. And then there's other types like surface treatment thickness non-uniformities that can cause anomalies. And then the foil thickness can vary occasionally on these big production lines. And then something that IBM discovered a few years ago called anodic conductive filament shorting, where there's migration of silver ions if that silver solder is ever used. So these are all issues that can pop up, and even though you've designed a perfectly controlled impedance environment on your printed circuit board, it's not guaranteed that's how it's going to be manufactured. So you've got to do quality checks on incoming.